Space Concepts seminar. Today's speaker, Dr. Vasile from University of Glasgow. I'll hand straight over to you.
Thank you. Thank you for inviting me, and good morning, everybody. So my name is Massimiliano Vasile, and I come from Space Art, the Space Advanced Research team in the University of Glasgow. I think that someone of you knows already this group. So what I'm going to present this morning is, say, an overview of some results that we have obtained in the last 4 years of research in Glasgow about how to deflect asteroids. And it's actually the result of 3 PhD theses. But I'm not going to present all the results, because otherwise we'll probably stay here till next month. But I'm going to present some interesting results, and in particular some recent results on the deflection of asteroids with sunlight. Okay. So before going into the equations and the results and blah blah blah, I'm going to present something about asteroids in general, which could be interesting if you don't know much about asteroids. Okay. So what we are talking about here is a family of celestial bodies that are orbiting in the solar system, and apart from major planets, of course, there are a huge number of minor bodies, and some of them are classified as asteroids, and some of these asteroids are classified as near-Earth objects, meaning that their orbit is intersecting in a way the orbit of the Earth. It's not actually intersecting the orbit of the Earth, but they are flying close to the Earth. So they have maybe a perihelion which is lower than the orbit of the Earth, and the aphelion which is higher than the orbit of the Earth. So there are many of these objects in the solar system. This is a nice picture in which you see how crowded the inner part of the solar system is. Actually, most of these asteroids are in the asteroid belt, and there are other 2 major groups in the orbiting around the Lagrange points of the Jupiter-Sun system. They are the so-called Trojan asteroids. But as you can see from the red dots, there are a number of asteroids that are actually flying towards the Sun. And of course, there are also some comets that are flying toward the Sun and are intersecting the orbit of the Earth. So it's a pretty crowded solar system. Among all the asteroids, normally we used to classify near-Earth objects in 3 major classes: the Apollo objects, the Athens, and the Amor objects, depending on the altitude or the radius of the perihelion and the same major axis. So you see here how they are classified, and as you can see, some of them are flying close to the Sun, and these are the Athens, and those asteroids are probably the most dangerous in a way, because when you try to observe the sky and try to find objects like this in the sky, it's difficult to see them if they come from the Sun, because the instruments are normally not able to pick up these objects. Their magnitude is very low, so you cannot really see them if you have the Sun in the background. This is, again, a graph that is showing a distribution of the asteroids in the solar system, and the part above the red curve is what is really worrying, because they represent probably the population of asteroids that can potentially impact the Earth in the future. So why are asteroids a problem? Well, these are just some examples of impacts of asteroids with the Earth. Normally, we have impacts with asteroids of very small size, so they don't generate any damage on the surface of the Earth. But there are a number of events, there's been a number of events in the history of humankind in which an impact caused a serious damage on the surface of the Earth. Of course, one of the most famous ones is the Tunguska event at the beginning of the 20th century. Luckily, these asteroids fell in the Siberian forest, so there was nobody there, but the damage was huge, and if that had fallen on a city, it would have probably wiped out completely a city. There are even more catastrophic events that happen in the history of Earth. One basically wiped out the dinosaurs, and was a massive impact with a kilometer-size kind of object. The Tunguska event was instead with an object with a diameter, estimated diameter of 100 meters. So a small object, if you think about that. And in fact, the most dangerous ones are not really the ones that could cause a global damage, like the one that killed the dinosaurs, but are the small ones. And for two reasons. The first one is that you normally know when a big object is coming towards the Earth, because you can see it, and it's relatively easy to predict also the orbit of big objects. And it's instead more difficult to predict and observe and find small objects like the Tunguska one. This is to give an idea of the frequency at which these events occur. So small objects are falling pretty often, but most of them, the ones in the green area, are not really causing serious damage. And most of them, in fact, are burning in the atmosphere. The ones in the yellow region instead are already dangerous because they can hit populated areas and cause major damages. And the ones in the red area are global killers. Okay, but you see on the x-axis basically the equivalent energy that is delivered on the ground. But you can see also that the frequency of impacts with the big ones is pretty low. Okay, so once every 10, 20 million years. While the frequency of the impact with the small ones is relatively high. Of course, it's an average impact rate. Okay, so it's not that actually we can say that every 50 years we have an impact with a Tunguska kind of asteroid. Recently, there was a major alarm for the expected arrival of asteroid Apophis. In 2004, an estimation of the orbit of Apophis was predicting a possible impact in 2036 after a close encounter in 2029.